Sounds
Hello.
good.
Okay, we don't get an announcement, but we are recording. Hello and welcome everybody. It is May 29th, 2025, and this is a community code review. I'm Newman, and we've got Code Cow and Harsha here to do some community code review. Uh, Harsha has brought some code that he is reviewing. And Code Cow and I will guide him through or be here to assist him as he goes through it. And
All
we
right.
are ready to go.
Yep. So I am the Don for today's session. I am here with two of my capos, Newman and Unspent or Code Cuff. So we'll be jumping into the code review. So before I jump into the code review, I have some documents open which are related to Icon, which are related to these imports right here. And the documents for these are open right here.
Nice.
And now jumping into the code, let's start understanding each line of the code one at a time. And if any one of the three of us does not understand a specific line of code, we stay on it until we are completely clear with it.
Yeah.
Are you guys good with that?
Good.
Yep, that sounds
All
good to
right,
me.
beautiful. And the three of us have access to the files right here, and we are using live share. And we are good to go. So let's start. So this is a hello world validator. And how do I know this is a validator? I know this is a validator because it says .ak, which means Aiken.
Yeah,
Aiken is a language which is used to write validators for the Cardano blockchain.
nice.
Uh, Validators, on the other hand, are scripts that either accept a transaction or reject a transaction. That's all a validator does.
Yeah.
Are you guys? Do you guys agree with my statement? A validator either accepts a transaction or rejects a transaction. So by the end of the day, it's a yes or no statement creator.
Yep.
Yeah, it's a Boolean, yes or no.
Boolean.
Yep. And is it accepting or rejecting a transaction, or is it doing anything else?
Ooh.
I'm just trying
Um,
to understand your understanding of it because this is currently how I understand it, but do you guys agree with what I think?
It's not accepting anything, it allows it
It allows it. Exactly. It
yeah.
allows a transaction.
But if
because it doesn't
yeah.
yeah, it doesn't change like when you send ADA to a validator, nothing happens. There's like no logic gates to send ADA to it. But when there's ADA in a validator, it can have
So
logic without spreading it.
I still am a little concerned about that, like sending ADA to a validator. I'm not looking at it like that. A validator is like a gateway that either accepts or allows a transaction or doesn't allow a transaction, right? And it is a gateway for that transaction. And if the transaction is associated with the validator, it gets to like control the transaction. Does that make sense?
Yeah,
Okay. So
Yeah.
now that you understand validators on a high level, and even we are trying to figure out what validators are at this point. But
So true.
so let's jump into the code. So we have import statements. The use statements are import statements. Whenever you say use, you're basically saying bring these functions or these utilities into my file. So it is saying from icon get something called collection, and from collection get something called list. So let's make sure we understand the statement. So let me close this guy. So we are in the icon standard library, and now we want to go to collection in the standard library. So let's go to collection. Oh, here it is. So I can, so you see I can here, and then we are going to collection.
Nice.
And in the collection, we are going to list. And we are bringing all the guys, all the utility functions that list provides into our file with this statement.
Oh,
Are we good to
nice.
go to the next statement? You guys cool with that?
Yeah.
yeah.
Okay. So the next statement is importing or using Aiken crypto verification key hash. So this is the syntax for bringing exactly one function into our system, as opposed to like all the functions from a specific module. Is that the right word to use?
Uh, hmm.
What do you call this? So there is Aiken, there is collection, and there's list. Are all of these called modules, or are there different names for these guys?
It seems like
Oh,
a good one, even if it's not called that. We could refer to it.
so collection is a module, and list is a
It's
yeah,
a
and
group of
list is
functions, right?
a
It's
function.
not,
Yeah.
yeah, because like you said, when we just do slash list, we import all of those functions.
All
And then
those.
if we
Yeah,
just want the one,
we are
then
using
we
this
right.
this this
So is
syntax.
it correct that all of the other things from crypto are not imported?
Yes, that's my understanding. So let's see. So we have Aiken crypto dot verification key hash. So we are in Aiken. When we click on standardly, we enter the Aiken, which is all of the things in this library.
Yeah.
Aiken is the library, by the way. And we go to crypto. And in crypto, we are specifically bringing in verification key hash. Oh, sorry.
Ooh, which is a type
uh, Verification with a
just above
capital
function.
V,
Just above function, I
verification
think.
key
Yeah.
hash. That's right. So verification key hash is a type. And what is a type? A type is basically data which is structured based on this type.
Yeah.
What do you guys think? Is that like a reasonable definition for type? It's data which is structured in a specific way, and that way is called the type.
Yeah, the structure of it is what we're discussing when we're talking about
Correct.
types.
Exactly. So this is a piece of data that has this structure. Oh, sorry. And the structure is like a hash of the verification key. So it says hash. This Blake 224 is the algorithm which creates the hash of this data, which is the verification key. Cool? Does it make
Cool.
sense?
Yeah.
Okay, cool.
Yeah, yeah.
Okay, Newman, like let's clear this. What do you
Yeah,
not
yeah. Well,
understand?
one thing, I mean, I guess, uh, I know that, yeah, yeah, but it's interesting there that, I mean, I'm not exactly clear about an alias, and then they've got the at symbol, and then
So alias
verification.
is just like, say, for example, unspent transaction or code cow are aliases for a guy who has another name, right?
Right. Yeah.
So this is also similar. So this is just by the end of the day, this is just a byte array,
Okay.
which is like a list of bytes, right? A string could be a byte array, like anything could be a byte array, right?
Yeah. And then,
So
yeah,
by
that's
the
right.
end of the day, it's just a byte array, as far as I understand. Do you agree with that, code
Yeah,
cow?
the
This
the
is just a
hash,
byte array.
right? Because it's a hash, and a hash is a byte array.
Yeah, yeah. And
No.
how are we deriving is we are using this algorithm
That's the
to
algorithm.
hash
That
the
could be SHA-256
or
or like
whatever.
pick any of your algorithms, right? But like in Cardano, we like the Blake one.
Yep,
Yeah.
yep. Newman, are we? No, like if you are not clear, you can still say it. Like what is bothering you?
Yeah, it's that the hash uses, I think, instead of the open parentheses, close parentheses, it uses the greater than and less than. And I think that's just if scrolling down in that. Are we in crypto? No. Yeah, it's just
We are in crypto.
that's just how the hash for in Aiken does. It's just a
So how about this? I'm going to copy this, right?
yeah,
And I'm going to ask the chat in my AI. So I'm right here, right? I'm going to use the chat.
yeah,
Okay, I'm going to open a new one. Let me move this guy a little bit here. And I'm going to ask it a simple question, right? Which is related to what you're saying.
yeah.
I'm going to ask it. Are you guys able to see my screen
Yep.
and
Yep,
the
yep.
chat?
We
Okay,
got that
beautiful.
in the
So
yep.
I'm going to ask it, what what does this stand for
Yeah,
in the above?
perfect.
And let's see what it says.
It's just a
Ah, fuck, I opened agent. I literally changed it to ask and then the agent. I'm gonna change this to 3.5 sonnet because that's cheapest. Okay, let's see what it's saying. In the context of this thing, this syntax represents a generic type.
Oh,
Parameterization in icon. This is similar to generics in other programming languages like TypeScript or Java. Let me break this down. Hash is a generic type that takes two type parameters, which is the algorithm type and the verification key type. Is a parameter specific what type of data is being hashed. So there's a verification key type. So the verification key type is a type alias that represents a hash of a verification key using the Blake 2B244 algorithm. This is a common pattern. But by the end of the day, to answer your question,
yeah,
whenever they're using this, it means a generic type. So
yeah.
does either of you know what a generic type is?
Yeah, ask. I mean, that would be a good one
I'm not before I
because I
ask, I'm
mean,
making sure both of you do not know the answer.
well, I mean, a generic type is just, is it also like a primitive type?
Yeah. What is a generic type?
I
Is
read
it the same as
I read those less than greater than symbols like
Mhm.
the types of the parameters. Like the result is the hash,
Mhm.
but to get the hash, we need to pass in the parameters of Blake and the verification key. But
Yeah,
Correct.
it's talking about types, not functions. But it's I kind of think of it like I would a function.
right, right. Because typically a function would have an open parentheses and a closed parentheses, but they've made a choice to use these chevrons or greater than, less than, and
But we use those symbols like in TypeScript, right, all the time to define things.
oh, that could be a freaking TypeScript thing. I'm learning TypeScript and it's
Oh yeah,
definitely opening my eyes.
that would help you. Yeah, because that's how you do it all in TypeScript. Is
Um,
these things, and so you put them all through your code, and it kind of defines it.
oh,
And so
okay.
totally, if you're not used to seeing that pattern, that could be confusing. But yeah, I think of it just like I do functions. It's just they use the structure because it is types. It's a little bit different, but I mean, generally, it's like it all kind of functions the same way.
Yep, yep.
So this is literally what it's saying. Generic types are more like templates or containers that can work with different types. They allow you to write code that can operate on different data types while maintaining type safety. Think of them as a way to create flexible, reusable code structures.
Oh,
Let me give you a simple analogy. A primitive type is like a box that can only hold one specific thing, like a box labeled only integers. Okay. A
okay.
generic type is like a box that can hold different things, but you have to specify what it will hold. Oh, I see. So literally that makes sense for me.
So it could be a Blake
This
254 or a verification key hash. Is that what it's saying?
and Blake
It's and
2B244 and verification key.
not one of them. It has to, right?
It
Interesting.
has to have both of them. Yeah.
It has to have both of them.
So verification key hash is of the type hash, right? And hash basically is derived from two of these data types, which is the Blake algorithm type and the
Mhm.
verification key type.
Okay. So it is and
Yeah.
Yeah, it says there in that number one, it says is a generic type that takes two type parameters. So it needs two types. Yeah, that's
Uh,
a good question.
User is algorithm applied to verification. This is different from primitive types because blah blah blah. So no, generic types are not the same as primitive. Generic types are more like templates that can work with different types. Okay.
Mhm.
Right.
I mean, I'm not completely clear where these guys are used, but I understand that they are basically means generic types
Yeah,
and they hold other types that are needed to define this specific type.
yeah.
Makes sense?
That's how I understand it too. There's a little fuzz, but I think it's okay to kind of just
Yeah.
roll with it, right? I understood everything you just said, so
Yeah.
Yeah.
Yeah. Yeah. That's
Yeah.
good.
As
That's a
long
good.
as we have a shared idea, then we can move forward. Because we can always change the shared idea depending on what we learn as we move forward. Cool?
yeah. Newman, how do you feel?
Yeah, that's
Yeah.
good. I mean, and I mean, thank you for taking the little side trip for me because it really feels like Harsha in the driver's seat is the one that should be sort of taking the side trips. But that definitely is a pretty
I
good,
No, but I feel like
disagree. Yeah,
what
I think
we
we
need
all
to
should.
do
yeah. And I like that
what we
as
need
a
to do is that we are at least all of us at least in the top level, which is like the Don, whoever the beginner is,
yeah.
and the three of us should be on the same page.
Yeah. Yeah, yeah.
Yeah,
Yeah, yeah. That's true.
I completely agree.
And I love it because there's no other spot on the internet where you can go through this and so it's like we're on yeah, like this
Dude,
is the place to
we
capture
we
those.
just spent 20 minutes looking at this hash thing. I mean, that is everybody jumps right over that.
Yeah.
But like we those are all good questions that we have, and like all of us are kind of
Yeah.
like we I don't know. This is exactly what we need to be
No,
discussing,
because
I
we
think.
are noobs trying to help out noobs.
Yep.
Yeah.
So we
For
have to go
noobs.
through all of those.
Yep.
Yeah,
Okay?
we have to. And yeah, so keep asking the questions. You know what I mean? Like, and let's keep taking the side things. I think in general we want to go fast, but like
Mhm.
really that's secondary. That's like, I don't know. Take the side quests and
Yeah,
let's
yeah.
figure it out.
Totally.
Yep, absolutely.
Love it. Love
Okay,
it.
so we are done with two statements and we completely understand these two statements, correct?
Yeah.
We went through two lines right now. Okay, the third line. So you want to import icon, primitive, and everything in the string. Okay, and the fourth one, and I'm sure you guys understand like this because you are basically saying the same thing as the first line, but you
Things
are
list.
just ending with the module string. So that means all the functionality of the string.
Yeah.
Um, and the last one is use Cardano transaction, and you're specifically calling out output reference and transaction.
Okay.
Okay. Are these guys clear? But if you want to ask the question, how do you know that you have to import all of these guys? When the people are writing this validator, they don't immediately import. They import some and then they start adding as they start working through their logic when people are writing their
Sure.
validator.
Yeah, those build up over time. Yeah. Like what do you
Yep.
start with? Yeah, you start with
These
knowing that you're going to need a verification hash or
Yeah,
verification
and
key
if
hash.
you don't know what you need, then you absolutely don't even start with imports. You
Yeah.
just start with whatever you want to start with and start writing import statements as you work through it. Okay, so
Yeah.
now we are clear with all of these guys,
Sounds good.
right? Let's move to the next one. So this one is saying create a public type datum, and the datum has a has what is this called, has a
Key.
datum is, I'm thinking of datum as an object with
Same.
like internal data in it. Like, so what are each of these lines called? Say for example, I have owner. Yeah, so do we have a word for this? Like, what do we call like internal data types? I don't know what the word for that is.
I'm not sure either, but this is how you would do it in JavaScript, right? It's just the data. It's like it's an object
Mhm.
of type. Well, maybe you would right in TypeScript you would do the type of datum here.
Yeah.
Um, but it's just a simple object. That's how
Yeah,
I read it.
yeah. I look at it as, so this is slightly different. So for example, if I say public type datum and I have this owner and then I have something else. Owner, it could be literally any word, goner. Okay.
Oh, you're right. This is not a function. This is a
Yeah.
Interface. Yeah.
So that means datum can be of the type
right.
owner or goner.
And then right in
And
Java, this would just be like a string, right, or whatever.
yeah, whatever. Like verification key hash is of the type hash, right? This could be of the type hash or literally a string, or it could be an int, or like for all I know. You know.
Yeah, yeah, exactly.
So datum can be a hash or an integer, but it's not, datum is not both of them. It is one of them. That is my understanding. Do you guys agree with that?
Correct. Yeah, you're saying what it is. An owner can only be a verification key hash. A goner can only be an int.
Correct, correct. And when it comes to datum itself, it can either be owner or it can be a goner.
Yes, correct.
Right?
Newman,
Well,
repeat that though.
it'll say datum dot owner, right? Like if you wanted to reference or datum dot goner, you know what I'm saying?
It would be datum is either going to be owner or goner. So you would do
So I am going to ask this because I am currently feeling like
Okay.
datum is either owner or goner, but I want to ask this question to this guy and see. Oh, sorry, I need to add this.
Yeah, those, I mean, those are stuff. Yeah. It's weird. It's like ask.
How do I read this statement?
Yeah.
Can I read it as datum is a type that can either be an owner or a goner?
that's it. That's how to read it. Because look at Ryan on line 23 and 24.
Okay.
Right? If you wanted it to be an owner, you would
Mm-hmm.
read this line like expect some datum
Mm-hmm.
with owner.
Of the
Okay.
owner.
Or if you wanted it to be goner, you would do that same thing here. Just like this. You're expecting it to be of type goner.
Yeah.
And
Oh
so
no,
these
but
are
I think what Newman says makes sense in this type, right? Oh, yeah. How would you read this? Would you read it as datum is of the type owner here? Or are you saying the owner section of the datum type should be saved as datum? You know what I'm
what I
saying?
what I read is datum can be either owner or goner.
Okay. Because
And
the AI is also saying something different. It is literally saying, uh, no, that's not correct way to read the statement. Let me explain the correct interpretation. This defines a datum as a record type, similar to a struct in other languages that has two fields, and it must have both fields. A field named
Oh,
owner of
that's
the type
interesting.
verification hash and a field named goner of the type integer. It's more like a container that holds both pieces of information together. Even datum, every datum must have both an owner and a goner. It's not either or situation.
it's confusing because they're right. That's technically correct. But when you use the datum, when you pass in a datum, it only has
Uh-huh.
one of them. It does not, right?
Really? No, because this guy Claude 3.5 could be wrong. So I want to make sure that is the case.
Okay, because
Well, this statement right here, right? Like, okay, so we
so
keep this datum with both types,
mhm.
and we don't have this line, or whatever. Actually, it's this. Okay, so all we need to do for this validator to pass is make sure that the datum has an owner. So yes, the type has a goner on it,
Mhm.
but the validator doesn't care about it. the validator only checks for this. So like when you make a transaction and you pass in a datum, it doesn't have to have goner on it.
No, exactly. No, I completely agree with you.
Right.
My
Yeah.
question is, so you are basically saying in this statement, all you are saying is the owner section of the datum is what we care about, right? That's all you're saying.
Yes. And so I think we were wrong. As soon as we added in a second one,
Uh-huh.
we need to make sure that that's here. So this is like saying rest, or like this is saying this would actually fail, right? So I was wrong, and Harsh is
This would
right.
fail. How did you know this would fail? What did you do?
Because it
It
requires
doesn't have
both.
goner.
Yeah, it doesn't
Yeah,
have goner,
yeah.
right?
It needs to go like this is like saying rest. So that this would pass if I had right.
Anything
Loner.
else? Yeah.
Okay,
You know,
got it.
yeah, it doesn't matter because it will catch all of them. Or we could write them out. Like this would also succeed
Yeah.
because the datum. Yeah, so I was wrong, and this is good because the datum does need this. And if we don't care about those, we can kind of just forget about them with this catch-all.
Okay. So this is basically saying whenever you're creating a type datum, it needs to have the complete structure, this specific structure.
Yes,
Ooh.
100%.
And when you are writing your validation logic, you can either say you only care about this part of the datum or this part of the datum uh, by using this structure, which is
Yeah.
like you say datum, and if you and in the flower brackets you mention which part you care about and put dot dot. The dot dot literally means I don't care about the rest, and you save that part in a variable called datum. Are you guys cool?
Yeah.
The only thing is that last part. You're not saving it in a variable called datum. This is destructuring. So
Yeah,
your
but
variable is owner.
So whatever
huh.
Does that make
is
sense? Like
So,
this is the parameter, is the datum,
uh-huh.
and out of that datum we
Oh, so this
destructure.
datum, I see. This guy is the datum right here. So this is not a random variable you created. So I can't put like something random here. Okay,
Correct.
makes sense. Makes
If
sense.
you wanted to label these differently, I believe you could.
Yeah. And then you just change it. Oh, look, it did it for you. Nice.
Okay. No, I completely understand now. So basically what we are doing is we have this datum here. We are basically getting a uh, a piece of information that exists inside datum and assigning it the name owner. Correct?
And we're not assigning it owner because it has to be owner.
Oh, because it has to be owner because we defined it here like
Yeah.
this.
But in you were correct in the sense where like in a normal programming, right? You kind of assign the variable and we have it because we are like now when we have this line, it's like we assigned a variable. But if we were to call this random, it would fit. Oh, so if you wanted to do owner
Of the type owner. Yeah. So you're giving this owner
random,
section an other name, which is the
right? I forget. Is this the way to
no.
do
So
that?
so I would think it'll be the other way around. So we can now I want to call this owner something else, and
Yeah.
I'm calling it my name. Okay, Harsha is of the type owner. Uh, I mean, that's what I think it is, but I could be wrong. Maybe this
Let
is
me
wrong.
look at my other code base because I did this before.
So, I mean, this seems like an alias, but
Yes, exactly. It's an alias.
Newman, how are you holding up? Hey, Newman, you there?
It's the other way, Harsha.
Oh, it's the other way. Oh, I see.
So this would be an alias of owner.
Ah, I see, I see, I see. Okay, okay, cool, cool. Makes sense.
Yeah.
So, okay, we understood what this means. Now we know how to read it. We are saying this is public means it will be accessible in other files. Public just literally means this is one file. Hello world.ak is one file, right? When you are saying my understanding is that this type can be accessible in other files. Say, for example, marketplace, I want to use this type, I can bring it there by using a use statement and start using it there. That's my understanding. Do you guys agree with that?
Yeah. So if we don't need it on any other files, we could remove the pub and it would work
Yeah.
on this local file.
Yes. Yes. That's my understanding.
Yeah,
Yeah.
and it would just say pub or just say type.
Just a time.
Yes, a
Yeah.
type. Yes. And what this is saying is their datum is a data, is a piece of data that has two parts, that only has one part at this point. But if I added one more thing, it has two parts. This data has like a verification key hash, has a piece called owner, which is of the type verification key hash. And where did we get verification key hash from? From here. And it also has another piece called goner, and that is of the type integer. But if I remove this, then it is only of the type owner, and owner is of the type verification key hash. All good? So we
Uh-huh.
have like a higher level name, and inside the higher level name, there is a piece of information of a specific type. Okay? Owner is just an alias, and it is of the type verification key hash. All good with this statement? So we are done with 8 lines of code already.
Don't keep don't keep score like that.
No, that's fine. I feel
Yeah,
like,
yeah.
we'll only get quicker eventually.
But two important things with Aiken contracts, like you're always going to see those, and if you don't, if
Always.
you've got just sort of a cursory understanding, it's going to catch up to you. You know,
I mean, you could always expand your understanding by
yeah, exactly,
trying to
exactly,
figure shit
and
out.
it
Yeah.
always changes. You know, it'll be different. Yeah,
So I
Yeah.
see I see a datum and that has the same structure, but then I also see a redeemer that looks like it has the same structure. Are those the same thing?
They are two different things because they have two different names. Because there is the owner and it is of the type verification key hash, and we know from previous research that verification key hash is an alias for just a hash,
yeah,
Yeah.
right?
Right.
And this one has a different data type inside of it. It is of the type byte array, but remember, a hash is also a byte array. So maybe technically they are the same thing, but they have different aliases. So we
Yeah.
need to use them based on these names or aliases that we have given. So it's like this. For me, it's like this. Newman is a person. I am a person, right?
okay,
So say for example, let me actually create a little fun data type here. Public type human.
yeah,
Okay. And here there are three humans. One is Harsha. My name is of the type, I'm going to say byte array. So byte array for me is the lowest type of data. No, a byte is the lowest type of
Right.
data structure. And a byte array is an array of bytes, which is pretty low level, I think, because
Yeah.
it's not giving you any more information about that data other than saying, hey, this is an array of bytes. Does that make sense, Newman
yeah,
and
yeah.
Unspent?
Yeah.
So here, Code Cow is another guy. His name is also a byte array. Uh, Kai, who is Kai? Uh, Newman is a byte array. So basically, this is literally the same as this. We are just saying
Different types of humans.
there are different types of humans.
Cool.
And this is saying there is only one type of redeemer.
Yeah.
I mean, that's a weird way to say it. Yeah, redeemer. Yeah. So there are different types of humans, but to build a human object, you need all of these types. You need Harsha, Code Cow, and human. Otherwise, you can't build a human.
Oh, so maybe those are like arm, leg, knee.
Yeah, exactly. They're like
They're
an arm,
parts.
leg,
Yeah.
knee. So you're basically building this human, and to build a human, you need all of these. Actually, that's a better way to put it. So I'm going to do arm, leg, leg,
It's actually a good analogy.
face. I mean, you know, for this, it's a slightly weird human, but yeah, the human has an arm, leg, and a face.
What else do
Um,
you need?
I mean, I guess I'm fine with that. Uh,
Cool.
yeah.
Okay. So yeah, that makes sense.
Like all both of you clear on these guys?
Yeah.
Yes, I think so.
Okay, so I'm going to like and by the way, the shortcut to like comment out something is on a Mac, command right slash.
Yeah.
Okay, cool. Okay, anyway, so we have defined the types here, right here. And if you're asking yourself this question, why did they define these types? What can be done with these? Do either of you have answers, or does this come later? When someone is writing this code, at what point do you think they wrote this part?
They wrote it after. I think they haven't written the import statements, and I think they haven't written these
Oh,
types yet. I think they've started at line 20.
They have started at line 20. Okay, let's start reading line 20 then.
interesting. Okay, that's good. That's good sort of thing. It's like where when you're dreaming this up, like where do you start? That's a great thing.
Okay. So in line 20, this is literally saying, hey, I am creating a validator which is called hello world,
Yeah.
and this is the logic of that validator. Okay, all of this below until the else fail.
Yeah.
This is the whole thing is the logic of that validator. Okay,
Uh-huh.
ready to move to 2021. We are just creating a validator with a name, and this is the syntax. Cool.
Yep, yep. And that's like a it's like a function, you know. I mean that reminds me of a JavaScript function, validator
Yes, no,
used
yeah,
to be like
that pretty
function.
much. And what does this function do? It either allows a transaction or prevents a transaction. That's it. Okay,
Right, because we established that from before. Like what does a validator do? It accepts or rejects
correct. A transaction.
a transaction, yeah.
Okay, so now in the validator it says spend. Where did this spend come from? Okay, let's jump into the thing. So
Nice.
this spend is called a script purpose. So that means what is this validator? What does this validator want to do? Okay,
It
so
wants to
everything this
spend.
validator wants to do are divided into these high level categories called script purposes. Let's get to script purposes then. Do you guys, is that fair, both of you guys?
Yeah.
Yeah.
Yeah, yeah.
Script context. Is it script purpose or script context? Script purpose, I think. Script purpose. So see, so each validator has the ability to do these things. And all of these things are called script purposes, which is it can either each validator can mint something, it can spend something, it can withdraw, it can publish, it can vote, or it can propose. These are all the things that a validator can do.
It's
Okay.
verbs.
Yes.
Yeah.
Yeah. It's basically verbs, validator verbs. And a validator can do one or more of these things. So it's not just always one thing a validator can do. It can do one or more of these script purposes.
It can do all
All
of
clear?
them.
Or do all of them. Yeah. Um, Clear?
Yeah,
Are we
that's
cool with
true.
script purpose? Ready to move on?
So our
Yeah, and
purpose is spend. Do we
The
have another
spend.
purpose?
so yeah.
We don't have another purpose. It's either spend or else fail.
Hmm. Hmm.
That's it. Else fail is like the default action of it outside of this. Is that
So
fair
our
to say?
validator has one purpose, or I
That
guess
is
it
to
has two
spend.
purposes. It can spend or it can fail.
Right.
Yeah, the fail is like a default purpose, so let's not call it a purpose.
It's not a
The
purpose. Okay.
purpose is just the spend, mint, or whatever these guys we saw.
Yeah, yeah, okay.
If it doesn't do this,
That's our
whatever the
boolean.
purpose is, then it fails.
Yeah, our boolean.
Yes,
Because
it is
because the
our boolean.
validator is ultimately a boolean. Hello world is either going to be true or it's going to be false.
Correct, correct. So this part, the what is this called? The script purpose also ends up like saying yes or no. Okay, and this definitely says no, which is a fail.
Yeah,
And this one also says if this is a no on a high level, if this is a no, then it goes to this guy, and this also says no, and that is when the validator fails. Cool.
yeah.
Okay. So now that we have the spend purpose, let's take a closer look at the spend purpose of this validator. What does a spend purpose do? For scripts that are used as a payment credential for addresses in transaction outputs, they govern the rule by which the output they reference can be spent. Got it.
Okay, wait a
So
minute. Wait a minute.
yeah, no. Let's like get
Yeah.
this clear. What is this saying?
So
Newman, can you read and
yeah,
tell me what it is saying?
for scripts that are used as payment credentials, is this, and just, no need to try to dig into it too deeply,
No, we should.
but but yeah,
But
but
yes, read it.
is this hello world, is that, is it being used as a payment credential for address? What's the address? And what is transaction outputs? When you take it apart, it does, all of a sudden it's not as simple as one would expect.
Exactly. So now let's figure this out. What is this saying for scripts that are used as payment credential, right? For scripts that are used as payment credential for addresses in transaction output.
Addresses and
Okay.
for
So
scripts are is it just saying spend?
yeah, it is literally just saying uh so for example, if you are spending something from a validator address derived from this specific validator,
Right.
then it has to follow the rules of the validator address, is literally what it's saying. And how do we know this? Let's try this out. So an address, I'm going to go to an address. So
Are we in
what is an
agreement that that line though that we read just made it more like is it just
complicated?
made it more
Yes,
Yeah,
100%.
okay.
100%.
Yeah, that's true.
Okay. But I just opened an address, and this is how an address is defined.
Okay.
How is the address defined? It is basically like a data structure, just like we spoke
The
about.
types.
It has a payment credential and a stake credential. Okay.
Yeah.
Okay.
And
And
the
those are just other
stake credential
types.
is optional. That means even if this part of the data structure doesn't exist, the data is fine. Make
Interesting.
sense?
Yeah.
I
Yeah.
mean, when it says optional, I mean, stake
I,
credential can be none,
It can be
is
none.
what it is
Yeah.
saying.
Yeah. Yeah. Yeah.
yeah,
It
it
can be
can't
some
be
or none. Yeah.
it can't be undefined or null. It has
Undefined.
to be
Exactly. It
it
has
has
to
to
be
be
none.
yeah, some.
Yeah. Now I want to understand payment credential. So I'm going to type payment credential here because I want to understand the type and where it's coming from.
I think it's going to be similar to the verification key hash.
Yeah. There you
So
go.
payment credential is an alias for something called credential. And so I have to understand what is a credential. There you go. So a credential is a general structure for representing on-chain credentials. Credentials are always one of two kinds: a direct public or private key, or a script.
There it is.
There you go. So it is either a script or a private or public key. So, for example, I'm using like an eternal wallet, right?
Yeah.
So I am using a private or public key to control this address. Okay. And when a script hash is controlling that address, that means that address lives and dies by the rules defined in one of these guys in the validator.
Right.
Make sense?
It's basically
So for
that
example,
is
in my
the
in my local
verification.
eternal this thing, right? What
Yeah.
does it mean that I control the private keys, private and public keys?
That means that
It
you have a
means,
verification
yeah,
key.
yeah, as long as I have the keys, all the UTXOs, all the UTXOs that exists in this specific wallet, say all the UTXOs, say where are my UTXOs? UTXO list. So all these UTXOs that exist in my wallet, I am able to control.
Yeah.
Okay? Make sense, Newman?
Yeah. And this is a fundamental thing, and yeah, this idea between a wallet, which is verification key and a verification key hash, and a script and script hash.
Yeah.
Um,
Credentials kind of like the keys, right? Like it's saying I have control over this.
Yes, I have
And
control. If I have these, and this can only happen if an individual is has control, that means they have the private and public keys. They have the verification key hash
that's like your
of that
wallet.
wallet. But if the verification key hash or like the script is the credential, that means how are the UTXOs controlled? They are controlled based on the logic of the validator. Anyone has control over the UTXOs as long as they follow the logic of that validator. Does that make sense when it comes to credential?
yeah, yeah.
Yeah, so the first one is like a wallet, and then the second one is a validator. So in order to,
I think both of them are wallets, but the rules that control the UTXOs in both these wallets are different. That's all.
okay, you would say that the validator is a wallet?
Yes, 100%. It's a wallet
Oh,
It's a
that
script.
because it also holds UTXOs, but the
Yeah,
UTXOs can be spent or something can be done with them only if you follow the rules of that validator that created the address or the wallet.
so is a wallet is just validators.
A wallet is what?
A wallet is just validators?
Yes. And the validator, so for example, if an individual is controlling the private keys or if or a verification key hash of a wallet, right? So the individual, the person, me, I am the validator
yeah.
because I am validating whether someone can spend the UTXOs or not.
That's right. That's right.
Does that make sense?
Yeah, for some reason I've never thought of it that way. I've thought of them as separate things. But yes, I guess certainly it makes sense. Like, yeah, because
So a validator is the script that controls that basically puts forward the logic through which the UTXOs can be controlled.
yeah,
And a wallet is just the placeholder or the
of the key.
name where the all the UTXOs are stored.
Oh, yeah. Okay, okay. I think I need to see a wallet back end. You know, that could help me
Right.
understand that.
Yeah,
But
no,
I
and
all that makes sense, Harsha. That is cool.
Okay, cool. Newman, you are cool as well.
yeah, and it's something it's interesting to hear you say or just to code count it. It's interesting to hear like that like different, frame of reference or sort of idea about it because that's definitely one of those that, working with Asteria, that was sort of it's like all of these um I guess to use that terminology, all these credentials and the logic or the validators, all of that is handled with script addresses as opposed to wallet addresses. So it's sort of a fundamental for me, a fundamental thing about how I see all of the smart contracts. So it's like, oh yeah, there are wallets and wallet addresses that hold things like UTXOs or NFTs, tokens, values, and datum in wallets, but there is another type of uh, address, and those can be validator addresses, and they can do they can do similar things. Yeah.
I'm also stuck there, Newman, because you just defined two separate things, but what Harsh is saying is like they're really the same.
Yes,
They
that's what I'm saying.
well, so but they have two separate constructors. They
Yeah,
function the
one's a
same, but
script and one's a wallet,
yeah,
right? Like, I mean, we're looking at it right here.
yeah.
So let me write credential down. 1 second. I'm going to create another type, or maybe I'll just replace this. Uh, so I'm going to create a type called credential here.
Okay.
Okay. Or is it credential or credentials? Oh, it's just credential. Okay.
Credit.
So this one is basically defined by two things, which is, wait a minute, maybe I fucked it. I can't write two things because it is either this or that, right? Am I getting that right?
I,
Uh,
I,
s-
you were on something, and I want you to just trace your logic, however far you can.
Keep going, man.
so I thought I could write a credential that would, credential type that would look like this, right? I'll just copy these guys. Um, uh, I thought I could write it like this, but from what now, but my current understanding of this, I feel like I can't write it like this because I think a credential can either be this or this, but not both.
That would have been my initial understanding too, because of how I've thought about a script address and the script controlling the validator versus the wallet controlling the validator.
Correct, correct.
So how did we even get here though?
Wait,
Can you
wait.
bring this back to the hello world? Like, why are we looking at credential? Maybe that will help
We
us.
we are looking at credential. Yeah, why are we looking at credential?
It's
Because
from
of the
spend.
spend endpoint. Because of the spend
So
endpoint.
let's
So that
yeah. So
means,
what are we doing with credential? This will help
so yeah,
from the
that's what
spend perspective.
script purpose p. So we are going to script purpose. Here the spend says for scripts that are used as payment credential for address in transaction outputs. So basically, we understood why the script and payment credential part from here, or at least we are trying to understand script and payment credential part from here.
Yeah, yeah. It's still
For
not clear.
address
So like,
uh-huh.
because we're not actually. This is not saying that we're passing a credential to spend, right? We would actually do that in the withdraw. You can see withdraw credential, but we're not even talking about that here.
Yeah. Yeah. So we are basically trying to figure out what this address means, like what a validator address means, or what this script address means.
Yeah.
That's all. So for now, my understanding is a validator address is an address that is derived from a script.
Yeah.
Yes.
Okay. Is that a fair thing to say and move on, or do you want to dig in a little harder into this?
A validator is a. I
So
don't
there
even
are
care.
two types of addresses.
Yeah, there's two
One
type
is a
validators.
user controlled address, and other is a validator controlled address.
Yeah.
A
Yes.
user controlled address is controlled by the user using the verification key hash.
Yes.
And a validator controlled address is controlled by a script.
Yes. That's it. That's the right way.
Yeah.
Fair enough?
That's
Can we
it.
move on for the time being and we can answer this question again later?
Yeah, yeah, it comes up. It'll,
It'll come up.
that's how the mental model gets layered in, But I think it is an important distinction. Um, yeah, yeah.
Okay. So yeah, so
But yeah,
so
yeah,
this
let's read this
sentence still
again.
is very very confusing, and I have no
But
idea
let's
what it is saying.
let's read it
Yeah.
again and see if if it
Oh,
changed.
I got it. I got it.
Okay.
The
They
transaction
literally,
outputs. When you have I'm thinking of the mesh of the off chain. When I have an output,
uh-huh.
that means I from a script's perspective, and I have an output. That means I'm spending from that script.
Mhm.
And so that's what I read there for addresses in transaction outputs. That's like tagging the outputs and just understanding that you're spending. So for scripts that are used as payment credentials in outputs as payment, it
Oh,
is. All
yeah,
this
I
is
get it
saying is
now.
spend. It's saying spend. It's just the
It
most
is,
confusing
yep, yep.
way to say spend.
I think the second line makes it clear. They govern the rules by which the output they reference
Yes.
can be spent.
Yes.
That's
Okay.
literally it.
We should make a fucking request to just delete that first line.
Well,
Yeah.
no. This is interesting because it's for scripts. That means not for wallets that are used
Yes.
as payment credentials. So a script that's used as a payment credential as opposed to a wallet that's used for,
Now again, like I think we
Oh,
should converge on like our
yeah.
the words we use. I am using the name wallet for both a wallet that is derived from a script and a wallet that is derived from a payment key
Oh,
hash.
okay.
You know,
Okay.
it's all wallets is what I am thinking. Are you guys not thinking of it that way?
Well,
I think there's a
So are you
script.
differentiating between the words wallet and an address?
I think a script can spend without the wallet.
No, with oh no no no
yes.
no no
I
a
don't know.
wallet. I'm
What?
just the word wallet and address. I'm using them as the same word. Are you guys using them as the same word? An address is just a place where UTXOs exist. It's just a pointer, basically, memory pointer. Think of it like that.
No, I wouldn't call an address the same as a wallet
Address is
because
not the same as a wallet. So
I
the
think
Mhm.
of an address as potentially a validator address,
yeah.
which,
Or like a regular address, yeah.
yeah, or regular address.
Okay, okay. So a wallet, so okay, let's get this right. So a wallet is controlled by an individual or an organization. That means they control the payment key hash. But an
Sure.
address
Yeah.
can either be a wallet or it can be a validator address. Am I
Yes.
getting that right?
Yes.
Okay. So basically when an address is controlled by an individual or a group, then it becomes a wallet. Are we all
Yes.
clear on that?
Yep.
I mean, this is just like our shared
Yep.
language, by the way. I don't know if
This is how
that's
I
the
think
actual.
about it.
Yeah.
Yeah, definitely.
Okay, cool. All right. So once we are there, now we have the spend endpoint or spend purpose for the hello world validator. So
Which is a
this is a
script.
which is a script, which is, yes, the spend
Right.
purpose is a script. We basically define the logic for spending or not
Yes.
spending. So I have a question here, and this is a question I have had for a long time. So the spend in the spend here, in when they're defining the purpose, it says output reference, right?
Yes.
So my question is,
Mm,
who is providing this output reference? And here there are not just output reference, but there are a bunch of things. There is the self, which is the transaction. There is the datum. There is the redeemer. Who is providing all this information? Or is all the information a part of the transaction, or what's going on? And why are they mentioned separately?
yep.
Can because I don't know the answer to this. Does either of you know
So
that?
I think the validator is only going to run when you're trying to spend the value in it. So if you can imagine, hello world is on, this is a script address on chain. And I use my wallet and I send 10 ADA to this script address in that we are calling hello world. So now the state of the validator of hello world is it's sitting there on chain with 10 ADA in it.
So
And
don't tell me in terms of 10 ADA, speak to me in terms of UTXOs, because I feel like
one
that's the most
there's one
fundamental.
UTXO.
Okay, you want to send one UTXO to an
Yep,
address that is derived from this validator.
I already sent it. It's already sitting there.
This
It's
guy's
already
good. I
sitting
think
there.
Harsh is
Okay.
leading you down a path right now. I think he's leading you. He does this to me all the damn time. He's doing it to you now.
This is the mob. This is what we trusted, right?
Yeah, yeah. Okay. Um,
Um,
so you sent a UTXO to this validator address, and this logic accepted. So
so what
does the
happened when I sent
validation
it there?
logic? Uh-huh.
What happens when I sent that UTXO there? Nothing. It just went there because that's how the blockchain works. I sent the one to UTXO. So now validator
So
hello
so so
world has
so
one UTXO at its address,
no.
and
So
it
I
has
have a small question before that statement. Like you said, you basically sent a UTXO to a validator address. So is the assumption that validator addresses cannot stop UTXOs from coming in, or can they
yes.
write logic for UTXOs to come in as well?
No, you cannot. You cannot prevent a UTXO from coming in.
That's interesting. I'm going to write that down
Oh,
somewhere. Um,
yeah, that's a good one.
this is an assumption, unless it's verified. Um,
It's verified, but it's okay because
Yeah,
it's an assumption that a lot of people will have
right.
because they
okay,
don't understand what a validator really is doing.
The
makes sense. Makes sense.
a
So,
validator can't stop.
so a validator can only control the UTXOs in the address, but it cannot control the UTXOs that are sent to the
Address.
that are UTXOs
I would
that
say like the question is, can a validator prevent UTXOs from being
from
sent
coming
to it?
in, from
Yeah,
being sent to it. Yes.
Can a
Actually,
validator control the UTXOs being sent to it?
prevent.
Prevent. Can a validator prevent?
can a validator um but, instead of prevent can a validator decide? I think that's a better, just because like I'm thinking about script and logic.
Okay.
Decide to accept uh, a UTXO.
Yeah. So they're right in that logic, it would be selectively prevent, but it's the same thing. It's like
Yeah, yeah.
logic coming in, which it
Logic on
cannot
the
do.
input. Yeah, yeah. Where does the logic happen? I guess.
Only on the outputs.
Yes.
Only on the
Yes.
outputs.
Only on
Okay,
the
so not
outputs.
on the inputs. Okay.
But yeah, but this is really important because, and it sounds like you had this question, and like this is what a validator is. So maybe ask the AI. Let's get a confirmation.
Oh,
Yeah.
there you go. That's already a prompt. Perfect.
So I am asking it, is this a correct assum- assumption for Cardano validators? Yes, this is a correct assumption for Cardano validators. In Cardano EUTXO, extended UTXO unspent transaction output model, validators, also known as spending
Oh,
scripts or minting policies, play a
interesting.
crucial role in determining whether a transaction can consume, which is spend, a UTXO. Here is how it works. When a transaction attempts to spend a UTXO that is locked by a validator script, the validator must run and return either true or false. If the validator returns true or false, it can be spent. If the validator, that's all spending. Um,
Right. Ask it my question of can a validator prevent UTXOs
Yeah.
from
can
being
a
sent to it?
validator prevent UTXOs from entering
Yeah, being sent to it.
entering an address derived from it.
Okay.
Yeah,
Uh, I mean, fine, whatever. Like,
Let's see what's
let's
happening.
hope the AI is smarter than us. No, a validator cannot prevent UTXOs from being sent to an address derived from it. This is an important distinction in Cardano's UTXO model. A validator can only control the spending of UTXOs, not their creation. Anyone can send assets to an address at any time.
Mm-hmm.
The validator script only runs when someone tries to spend. So I think that's a pretty clear no, you can't stop shit
yeah,
from
coming in.
coming in.
Yeah. So
Okay,
it's
that
like a
makes sense.
vulnerability, right? Because like one of the things that could happen is I could send your validator, like this hello world, I could send it a billion NFTs.
Yeah.
And then when you try to spend from it, you have to deal with all this logic of these billion NFTs to like spend what you want
Right.
because
Yep.
I flooded it with these things. And then it's actually like, you're right. So it's an important vulnerability that I don't understand fully, but it's because of this.
Yep. So basically, you cannot stop shit. Okay.
All right.
So that is why all these motherfuckers can send scam tokens to our wallets,
That's
right?
right. I was
Yeah,
just about to make that.
yeah,
Yep.
yeah, definitely. Nothing you can
And
do about it.
Okay.
I do want to be
Cool.
mindful of the time.
Oh, what time is it? Oh
It's,
shit, 11:30. When did we start?
I think we started about an hour and a half ago. Um, this is
Okay, let's I mean we're almost there. Let's get this done. Maybe we'll look at the tests later, but let's get this guy
okay.
done. What do you
Okay.
guys think?
This is another thing that Harsha does,
Yeah.
FYI.
I guess, yeah, I think we could continue on. We've also like have figured out a little bit of a flow,
Yeah.
and I feel like we could continue on through all of the validators and just keep going. So at what point do you call it quits? I don't know.
So,
Um,
yes. Uh, I mean, in general, I would say let's have like a 1.5 hour time limit. How many ever lines we go through, and then we start from the next line.
I could do it more as a project and say it's this whole validator or nothing, because maybe that's how it works. If because I guess like I am flexible if we need more time. Um, right, we can do that. But I also think it should be a goal of us to I don't know. I guess I don't know what I'm saying. It's like maybe I want to limit the rambling, but at the same time I think this is exactly what we need to do is the
Okay.
rambling. We need open time limits. We need to just kind of
Yeah.
go wherever we want. So I don't know.
Yeah, I mean, I don't know either, but like, okay, I'm not going to make decisions for every week. I'm going to make a decision for now. Let's get to
Let's
line
do it.
30
No,
for
no,
now.
Do it.
this
Do
So,
it.
is the fun part. I mean, this is the kind of the fun part, so let's do it.
Let's get to line 30.
okay. But before I get to line 30, I still have questions that I need answered.
Of course. Let's do it.
These motherfuckers, like these guys right here, datum, redeemer, own reference, transaction, where are they coming from? And I can see that these guys are being used in the logic, but who is providing them? Where are they coming from? Are they all part of the transaction? This part I need clarity on. Do you have clarity, either of you?
Yeah, I think it is all part of the transaction. It's now we've established that this function, this spend function only runs when it's
Uh-huh.
spending UTXOs. It has already had a UTXO loaded into it, and now it's ready to spend that. And so that doesn't happen without a user saying, like creating a transaction and then broadcasting it to the blockchain. And then the blockchain, the validator will run and try to spend. But like the user needs to craft the transaction, and when they craft the transaction they need to give it all of these things.
Oh, so when they're crafting so they are basically saying the only thing that is being inputted into the validator is the transaction itself. And
Yeah.
these guys are basically literally everything else is coming from the transaction. Am I
So
right?
that's how I
Because
think
I
of
see
it.
data. Yeah.
Yeah, they label like a specific part of it transaction, and so I think we have to
Mhm.
be a little careful. But the
Mhm.
way that you've just described it as like one thing being sent to this, and it's all a transaction, that's how I think of it. But
Okay.
technically, they right, they have self
No,
there
as long as all of these are a part of the transaction body, assuming transaction is an object and all of these are different sections in the transaction, then it would make sense. So that is why I'm going to quickly take a look at transaction.
Well, I think that may have been a little wrong.
Okay, no, let's see. I'm making an assumption and I'm
Oh,
happy to
look.
be proved wrong.
Yeah. Good. This is good because maybe you're right. Because look, there's the datums and
There is the
the redeemers.
reference. No, there's okay. What are all of these things? Datum, redeemer, and output reference.
Yeah,
So datum, does it
we
have
have.
datum? So it says datum, yes. So there is datum,
Yep.
and there is redeemer. Let's see if there's a redeemer.
Just
Oh, there
above it.
is redeemers right here,
All right. What's the next?
and output reference. Output reference. Wait, I know something. I know output reference is a part of inputs.
Yes,
So if I go to this inputs, this is a list of inputs. And if I go to one input, it is made
it'll
of
all have an output.
output reference
Yeah.
and output. So that means basically all those guys
Are
are
all
a
part of
part
the
of this
transaction.
transaction.
So why are we pulling them out here?
Yeah, yeah, why are we pulling them out? And specifically, I don't understand these underscore ones. This underscore one basically means, hey, I'm not using this guy.
Yeah.
Correct.
So why are you even putting it in here?
Because they require us to do it. It's like remember we were talking about the
Oh, wait a minute. They do require us to do it. Okay, I'm going to do
yeah.
this script. Is he a script?
It is weird though. I agree. Why are we pulling those out? Because we also pull the transaction.
Yes. So output reference, because it is specifically saying I definitely need this guy. I don't care for the rest, but I definitely need this guy. So when you are writing the spend, you might not even like put these guys, you don't even have to put self, but you definitely have to put this for the spend to activate. Make sense?
I think isn't self that output reference? Self is oh no, sorry.
No, no,
No.
no,
I'm
no, no.
I'm wrong.
Self is the
I'm
whole
thinking of own rep.
transaction. This
You're right.
output reference is literally
That's what
in
you're
the
spending.
input.
That's the UTXO that's being spent.
Yeah, exactly. That's the UTXO that is being spent.
Right. So
Yes.
you're saying if you didn't include that UTXO, then you can't spend anything, which is
Yep.
obviously true. You're not spending anything. And what you're also saying is you could spend that UTXO without passing the datum, the redeemer, or the self.
Exactly.
But I
Exactly.
think I think the self is the passing of it. So like you couldn't even pass right.
So
You
so
could
all I'm saying is, so in this, even if I do this, say for example, right? Even if I do this, it will be fine because I can define the self somewhere else, no?
derive from the output reference.
Yeah, because like the assumption is the transaction has to be passed because there is no other way to do this. A transaction is being passed and we are evaluating that transaction.
Yeah. Yeah. So that's the transaction, and the transaction includes a UTXO that's being spent, which is the output reference.
Exactly. So, but I can do this for all of these guys, but I can't do I can't comment this guy out because it's an absolute necessity as imposed by
Same with the
this.
self transaction, because if you don't have a transaction, then you're not doing anything.
Yep, yep. Exactly,
Right.
exactly.
So I think you could, yeah, I would exactly. And then the redeemer and the datum, like those guys, I agree, you don't need them.
Yeah, those are just guys that we are. Yeah, these guys are being self-defined, right? Or
So those are like like maybe self is like this in a React class.
Oh yeah.
So we don't know shit about React at all. So like
Well,
this
no,
and
I think
Okay.
self are the same
that
shit for
sounds
me.
right. That sounds right.
What do you
Self
guys
is
what
like
do you
this.
use to coding in?
I mean, we are used to coding like whatever, just like read the documents at that moment in time, make sense of it, and code
I
whatever
would say
language framework.
JavaScript is my like like that's the
Yeah.
one that's the one that I've taken the
So
most
you've
courses
seen
in.
this,
Yeah,
right?
and it's
Yeah,
always
yeah.
confusing. This dot, the fucking this dot.
It's like a class thing, and but anyway, I, I think of self kind of like this. It's like it's yeah, it is a transaction. So, anyways,
So the fair assumption is this is compulsory. This is compulsory when you're writing a spend. And these guys, you have to put these guys in there if you're somewhere using these guys in your logic.
um, no, because they're all compulsory in Aiken. We need all four lines written. You can't actually
Wait, you
comment out
need
the
all
datum.
four lines? So, but this guy literally says, I only need this. No?
They we, I mean, let's try it. Run it. Run some tests.
Yeah, I'm going to run.
I think if you comment out datum, it's gonna
Yeah,
fail.
I'm going to let's see. No,
Yeah.
but see, I if I comment out datum, this part
Okay,
will
you're right.
struggle, you know.
Comment all of that out then and make it
So
just
I'm going to comment
return
this
true.
guy out. Oh, sorry, what is this? Um,
Here, can I do it?
oh, yeah, go for it. So now I'm going to comment these guys out.
Yeah.
I can't comment this out.
Oh, and this would get us to always succeeds.
Yes.
Yes, yes. Okay. Fair?
Yeah, yeah. This way, I think we're gonna need them. Cool. That's my guess.
Yeah.
Newman, what's your guess?
I don't. I don't know.
All right, run Aiken check.
I'm oh, we can just run Aiken check. We
Yeah,
don't
just
need to
run the
write a
test and
test.
see.
Oh, you're right.
Well,
You can run Aiken check.
I
That's right.
mean, and it's because it's gonna send some data. It's gonna send all that stuff, and it's just hopefully the always succeeds.
So,
I'll just say whatever. It doesn't
um,
matter.
so we are
Yeah, all
in
the
week
tests would
0.
just pass,
Uh,
right? Because it is always succeed.
oh shit, I think I wrote something somewhere because okay, I'm just gonna
Ugh.
Aiken check. One error. Valid hello world.
Oh, is it not? Is
Unknown
it?
variable is true. Wait a
Is it,
minute. No,
is
no,
it
no.
capital true?
It is our thing. But I'm just trying to see what it is saying. Why is it saying true is the unknown variable? So this is sketchy.
Does it need to be capitalized? Try it again.
Yeah.
Oh yeah. Oh, maybe that's the case. I
Did you
can
forget to
check.
record it? Not enough
Yep.
arguments.
Where does
Okay.
it say? Oh, if you please
Just do
add the
one at a
3
time.
missing
Just do one at
arguments.
a time.
So datum, not datum. What's that? Fucking code cow is right.
Yeah.
Code cow
Because
is right.
if we
So
don't want them, we need to. You do this.
yep. You just put that underscore if you're not
If
actually
you,
using them in the logic.
yeah, instead of commenting it out, you do this thing, and it just says ignore this, but it still needs to be there. We need those 4 lines.
Yes. So I'm going to write a comment here. Spend. Uh, I'm going to say spend script purpose always needs datum redeemer output reference and self. Always needs datum redeemer
Output ref
output
and
ref
transaction.
and
Don't say self.
ts.
Yeah, exactly. because self is you can name these whatever you want.
Yeah,
These
yeah,
are
this, yeah, you're just calling transaction alias name as self. Okay.
exactly.
Okay, so now that is clear. So these guys are compulsory in literally every sprint. Okay, now I think we can yeah. Okay. Okay, so I think this is pretty clear. I don't know why it is compulsory, but I just understand it's compulsory. Okay.
Yeah, I think I agree because you made a really good point. It seems like we could just do the output ref and then derive everything from that. Or
From the
like it seems like
transaction.
it could just be one thing and then all of them are like sub values on the big object.
Yeah, on the big transaction. Yeah,
Yeah.
that's what I thought, but obviously we need all of these guys.
Yeah.
But if you're going to put all of them, we are only basically saying we know the types of these guys, right? And we are only defining types. We are not defining any values. We are just saying datum is of the type optional. Redeemer is of the type redeemer, because and all of this we are deriving from uh, transaction. So we are all basically copying these types basically that are defined here, right?
Actually, the redeemer is our custom type, I believe.
Yeah, redeemer is our custom type. Yes. So datum is
Also
also.
our custom type. Why don't we rename those to something?
No, wait a minute. So
Yeah, that's right.
no. These are not our custom types yet. Are
Yes, they
they?
are.
No, this
Yep.
is the custom type. So
Yeah, this
this
is line
redeemer
10.
is custom type. The option.
Option's not custom,
Oh,
but the datum.
option is not custom, but datum is custom. And the
Yep.
reason we are using option is because fundamentally datum here, like let me show datum.
Yes.
Datum is of the type option
Yes.
because datum is of the type. No, it's not of the type
Oh,
option. What the fuck is this?
no,
Datum can be no datum. It can be a
that's
datum hash or an inline datum.
you're right. It is of type, or you need to call some on it. That's all I know.
No, are you sure you need, because like if you
The
need to
first
call
one,
some,
yeah, it's
it
datum
is.
optional, right? That's why a lot of the validators do datum opt. It's because
So
it's
datum is
abstraction.
optional, but when you're not having any datum, this is the type that happens. It's not some or none. No datum is the type that ends up there, not none.
Oh, really?
But that's what these are, right?
Yeah.
Actually.
Go back to the code really quick. If try to do right, if you took away the option and just passed in datum, that would fail, right?
I I I don't know.
Make
You
it
just do I
always
can check,
succeed.
right? I
Yeah,
can
make it
check.
always succeed though. Hold on.
Oh, yeah. Make it always succeed. Yes.
What I forget now. Was it capital?
Yeah, capital. Yeah. Does it end with a comma? We just write true.
True.
Just true, right? Like you don't even need a comma. Okay, that makes sense. Okay, so I
There we
will
go.
clear this guy
So what
and
do we think
say
is going to
they
happen?
can.
I think
So what we are thinking is going to happen. Wait, what are we doing? I forgot what we were doing. I
we
lost track.
changed this from option.
Oh, okay. So we
Oh,
changed it from option datum
to
to
just
just like
datum.
datum what we created,
Yep, yep.
Yeah.
you know? So let's see.
Because
They can
what we're saying, what we're trying to figure out is this datum here. What does this need? Is it of type option or can it be just of type datum?
Yeah, see, if I'm inferring the following type option datum, but I found see, this guy
Yeah.
is saying it has to be option.
It has to
But why
be.
is it option? Then what is this deal? What is the deal with this shit?
I think we need to look at the spend. I honestly, I don't know.
I'm going to write this comment, and then whenever or whoever is smarter than us will have to tell us this shit. Okay. Um, why is datum uh, datum of type option, while the Aiken docs say otherwise.
I think
Okay.
it's because this is not like this can be called optional or whatever, right? That's a better way to read this. And so you're not actually, this isn't the type datum that you were looking at in your docs. This is something else. This is an optional type of datum. And so where that says it in the docs, probably somewhere connected to spend. I'm not really
But
sure.
I'm like, I'm gonna just say spend. Uh, There's nothing called spend, so
It's the
script
purpose.
purpose, yeah.
I know, this is going to bring us to what
Uh,
we found last time.
yeah, and like it says nothing else.
I know.
Uh,
This is, when I was first trying to learn, I ran into all these like dead ends. To me, it felt like a dead end where I just couldn't trace it
Right.
following the docs. And it's
mm.
what was really helpful to like join the course and to, just work with code because I mean, it's like, I don't want to say that the docs are incomplete because they've done all this work and stuff. And I probably just have an incomplete knowledge, but it feels like, sometimes you hit these things. Like, how do we find out, right? What we're talking about right now, this optional datum that is part of
Yeah.
the spend thing. Why is it optional? Where does it say that? And all we can see is a spend with an output reference. And then you're led down the thoughts that you
So
had, which makes
like
sense.
one other way of diving deep is
Oh,
to
okay.
literally go to where it is defined
That's
and
what you
check here.
do. Yeah.
So it is of the public type datum, and it says no datum, datum hash, inline. How this, so this is literally defined.
Inline datum is sum. That's a sum thing. So
Oh, okay.
uh,
So
do we
inline
need to
datum.
find the spend function in the docs, in the actual code?
Let's see. Script purpose. Let's jump in. Hey, minting script purpose. No, look at this. It is literally written like this. What is this? Like, are these the actual docs? Is this where shit is defined? This just looks like comments.
It's
Yeah.
above it.
It's a what?
The comment is above the line. So it starts at 24.
For
Right, right,
scripts
right,
that
right.
are used as payment credentials for address in
Yeah, it's the
transaction,
same, the same
it's the
that's in
same
the
shit,
docs.
yeah.
Yeah.
No, but I thought this would be the place where they're actually building out this function or whatever this is, like this tag or whatever. Hmm.
I think it is, right? Like it is. That's why we're seeing it. But for some reason, we're missing what we need to be, where our questions are.
Yeah.
Um, Also, oh, look, that's capital S because that's type. We're not looking at that. We need lowercase s. It's an action.
Oh,
This one,
perhaps.
That's
Yeah.
the
spend.
type.
Oh, this is the type.
We need the function of spend. Or I guess that's
Okay,
what I'm looking
I'm
for.
gonna, yeah, so spend, let's see.
Oh, what the fudge? That could be it.
Here, this is, oh, look at this guy. I mean, no, wait,
Yep, that's good
this
because
is
look at that.
literally
Just
it.
say data. Yeah.
This is literally it.
Find
Look
an
at this.
input by its output reference. This is typically used in combination with spend script purpose to find one's own input. Oh yeah, okay. It's just an example of to get
Of find
own input. Yeah,
query.
Okay.
fine. Yeah, exactly. So, but we still have not found the definition of that spend function that
We
takes
haven't
these
found
four
that
parameters.
definition, and we don't know why this datum is
It's type
optional.
option. Yeah. So okay, we're close though. How do we find that spend? How do we find the script purposes actual functions in the code?
No, we just do spend, and there are only three places where spend is with small letters. So we'll just see if we can find it. If ever it is this,
Are we sure it's in transaction.ak?
I don't know. I'm not sure actually. I don't even know where to look.
Yeah.
Standard library is where we look, I would think, and we have library in library there is icon and Cardano. So I would think this is an icon thing. And in icon,
Yeah.
script purposes is in, one second, script purposes is in, so Cardano transaction. Okay, oh, it is in transaction. Okay.
Those are the types. But again,
Oh, these are
functions
types.
on the left bar, you see it, functions.
Yeah, but
What
this only is three functions.
That's it. That's all that is.
Yeah.
Why? Okay, so never mind.
Well, you know,
Oh no, it's farther down.
wait, what am I looking at? Wait, are you talking about this guy?
No, sorry. Let me. I'm looking myself. I should stop talking out loud.
Hmm. Okay. So I'm going to put a couple more comments. So wherever I'm stuck or I don't know why is datum type optional, but before that there's a high spend script always needs datum redeemer returns. Okay, I think both of the things that I know. Oh, one more question I need to ask. One more comment I need to put in is this. Uh, in Oh, spend is small letter because this is a function. In spend script purpose, uh, 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 the only only the types are
Got it.
uh, inputted as params. Does
Go
this
to
make sense?
akinlang.org
One second.
language tour / validators.
Akin Lang.
The
You're,
main Akin website.
This guy
you're right there. No,
or
the
No,
this
the
guy?
yeah.
Yep. And then on the left, go to language tour on the left bar.
Left bar,
Scroll up.
language tour. Is there like a
There
search?
it is.
No.
And then validators.
And
Oh,
go down. Yeah.
validators. Oh, here it is,
And
validators.
then
Okay.
scroll down to managing optional datum.
Okay, I'm gonna.
There it
Okay.
is.
Managing optional datum. Spend handlers contain an extra argument, the optional datum, which may be set with the output when an asset gets initially locked. Because there is no way to enforce that the datum is present,
Yep.
you cannot prevent anyone from sending locking assets
Look at that.
to
That's
slash
exactly
in
what
your
we're talking
validator.
about.
Yep. That's exactly. And we discovered that, right? Like we came to that
Yeah.
conclusion, which is cool.
Okay. It always produces an option. So they're basically directly saying, hey, it always produces an option which is like datum. But is the
And why?
answer and
And
why?
why?
Where is why?
Because you can't prevent anybody from sending. You can't say a datum has to be there because there is no, like, the only way a datum gets there is from the transaction. When you craft a transaction and you send a UTXO somewhere, that's when you would put datum on it. And so this validator
Oh,
can accept UTXOs that look like anything because it can't enforce it. So the reason that datum is
ah,
optional is because it may be there or it may not be there, and there is no way to enforce it, which is pretty cool because we just came full circle.
ah.
Yeah, we did.
Okay, okay.
Yeah.
Okay, makes sense, makes sense. So
And
because we cannot stop people from sending UTXOs with datum or no datum, We
Yes.
have to make datum as an optional thing.
When we're spending it, because when we're spending it, we don't know if it's there or not. Yeah. So see how they call it datum opt
Mm-hmm. Mm-hmm.
in the actual validator, like
Oh, in the
spend
access. Oh, right here. Yeah,
datum
yeah,
opt.
yeah.
Right, because like they're saying it's optional. So I think our hello world, it just calls it datum.
Right.
And I would suggest it should be datum opt. I mean, because it's just that's what it is. It's an optional
It's an
datum.
optional. Yeah, yeah. I mean, maybe we can standardize it in whatever we write.
Yeah.
Yeah.
Well, it kind of is, right? Like we're a lot I've seen a lot of code that uses that datum opt.
Okay, fair enough. Like if everyone
That's
is
the
using it,
way to
I'm
do it.
down. Okay. Okay, so this is why datum is optional. Okay, that is clear. Okay. Fucking, we got
We
through
did it. I mean, that's
this.
a good why is datum optional. That's good.
Yeah, why is datum optional is definitely like the headline from this session for sure.
Okay.
Yeah.
So does someone want to write the answer to it in spend only types are inputted as parameters? Why is datum type optional when a can doc say otherwise? Can someone, oh, sorry, can someone like put this Newman or unspent? Do you guys want to
Okay.
take that?
Why is datum type optional while Aiken docs say otherwise? Well, actually, Aiken docs don't say otherwise. So that's the first thing that we should do because we just found the answer from the Aiken
Yep,
docs.
yep.
But datum is optional because when we are actually spending the UTXO, datum is optional. Okay, I got it. Don't worry, guys. It is optional because we can't control how UTXOs are locked out the validator. Spending only happens when we try, only happens after UTXOs have
Has
been
arrived
locked.
at the address.
Yeah, have arrived.
Yeah.
Spending only happens after UTXOs arrived. Thus, we uh,
Does
we
it
have
is
to
logical to
prepare
make
for.
datum optional because we don't know if it exists or not.
Thus, we have to prepare.
And it can't, yeah, we don't know if the datum is there or not. Yeah.
Yeah, yeah. So basically the most logical thing we can do is say datum is optional because we can never decide beforehand whether it will be there or not.
Yeah. How do I finish this line though?
Spending only happens after UTXOs have arrived. So it is logical for datum to be of the type optional because we cannot decide beforehand.
We don't know before. I don't know. Oops. I think that's fine for right now.
Yep, yep.
Okay. Well,
All
And
right.
I think we got to line 31.
that's
We
So
are in the body of it. We are in the body of it.
come on. I'm hearing the bells here. Uh, yeah.
yeah,
But if you
It's
we
12
don't,
o'clock.
we can keep going in the next time because this is still week 0 and we're really just I mean I'm angling that we close down now. Um, have a short break,
Okay,
come back.
if you're closing down now, I'm going to put like a comment here.
Yeah.
This, I'm going to make this capital. This is
Yeah.
where we stopped
Yeah. And then just put today's date, uh,
stopped on
May 29th.
week
Week 0.
0.
Yeah.
Oh shit, week 0. Date is, what is today's date?
5/29.
Is 12:04 p.m.
Yeah.
Not 12:04 p.m. is not the date. What is it?
Yeah.
May 29th.
May 29th. Yeah.
So guys,
Yeah.
I call this a smashing success. I think you're right. We have lots to figure out, and but like what we promised, what we agreed to was an exploration
Yeah.
and these
Mhm.
videos, which we've done. We've explored and we've created a video. So
Yeah.
I think this is great. And we'll either move fast. Well, I don't know. We'll figure it out as we go. Um, but I call this a success. I don't know if you would too.
Oh,
No,
definitely. And
I absolutely enjoyed this session. Like, I don't know if, by the way, before I start talking, let's spend 5 minutes to talk. But before that, I want to stop my live share session. How do I do that? Like,
yeah,
Oh, at
let's
the bottom, you can in one of those
it's
things.
oh,
It'll let
stop
you.
collaboration session. Yes,
Yeah,
got it,
and then
found
I'm
it.
kicked.
Okay, perfect. Okay, so Newman, can you stop recording?
yep,
Say
yep.
bye and stop recording.
Yep. Okay. So this was week 0, the first sort of shakedown cruise, if you're familiar with that metaphor, where we sort of kicked the tires. We got it. We spun up the live share, which I thought worked out really well. Um, and we ran through some of the process. Now we're gonna shut this recording down, and then we'll meet. We'll discuss like what we learned and how we'll move forward. But. We'll be back soon with week 1. Week 1 is on the way. So thank you so much. Bye, everybody.